Hi everyone, it's Miss Costa here, and in this video I'm going to be taking you through some revision for the paper 3 higher tier, which is on Monday the 13th of June. Okay, so to start it off, we've got some quadratic equations. Now here I'm being asked to rearrange this equation essentially to write it in its quadratic form. So the first thing I want to do is expand this out. So x times 5x would give me 5x squared. Take 7x equals 19. Now, how can I write that in its quadratic form? All I need to do is subtract 19 from both sides, and then I'm left with a quadratic equation. All it means is write it in the form where blah 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 equals 0. So you're just rearranging it to make this expression, this equation, rearrange it to make it in its quadratic form. And that is all. So perhaps you need to say that I might ask you to list the integers. A would be 5, B would be -7, and C would be -19. Okay, so here you've got a nonlinear simultaneous equation, and all that means is that you've got one equation that is linear, one that is not. So it could be quadratic, it could be cubic, it could be anything. So first thing we want to do is rearrange our linear equation so that it has a subject, either y or x. So the easiest thing we could do is add x to both sides, add 3x to both sides. So y is 3x plus 17. Now that we've got that with a subject, we substitute it into our quadratic. So wherever I see a y, I am going to write 3x plus 17 because I've rearranged it to figure out that y must equal this. So I'd say 3x plus 17 equals x squared plus x plus 2. Rearrange that to get it into the quadratic form, which is ax squared plus bx plus c equals 0. So let's take 17 from both sides. So not 0 yet. 3x is x squared plus x, take 15, and then take 3x from both sides. So 0 equals x squared, take 2x, take 15. Now I need to factorise it. So what are numbers that multiply to make -15? 3 times 5, 15 times 1, and also add to make -2. So I would say -5 plus 3 gives you -2. So I'd say x minus 5 and x plus 3. Let's just double check. -5 times 3 is -15. -5 plus 3. Yeah, perfect. So when we are solving an equation, we kind of, I don't know if I've already done this, I can't remember. Okay, let's do it anyway. So when we're solving, we want to imagine that you had 3x equals 0. What would you do to both sides to figure out what x is? You just divide by 3. So you'd be left with x equals 0. And that's what we do here as well. We choose one of the brackets and we divide both sides of the equations by it. So if I divided by x, take 5. 0 divided by x, take 5 is 0. So I'd just be left with 0 equals x plus 3. So therefore, x equals -3. I do that again, but with the other bracket. So I'd be left with 0 equals x take 5. So add 5 to both sides. Therefore, x equals 5. So your first part of your answer is x equals 5 and also x equals -3. Now, with quadratic simultaneous equations, you're going to have 4 results, 2 sets of coordinates, because what is a quadratic in a linear equation? A quadratic looks like that, linear graph looks like that. So the coordinates, when you're solving it, you're trying to actually find the coordinates. So you're going to have 2 lots of x's, 2 lots of y's. So when x is 5, let's do it in a different colour. we'll substitute into our first linear equation. So let's use this one because it's the nicest one. So y equals 3 times 5, 15 plus 17. What's 15 plus 17? That would give you 32. So when x is 5, y is 32. You could write it as a coordinate, 5, 32, or just leave it like this. So that's one of your answers. And the next answer here, we substitute x is -3, so y equals -9 plus 17. So 17 take 9 is 8. So when x is -3, y is 8. So your coordinates would be -3, 8. And that's your second set of answers. Okay, so quadratic simultaneous equations always going to have 4 answers. 2 lots of x answers, 2 lots of y answers. So here we've got a nice little algebraic fraction, and we want to simplify it fully. Now, if you've got an algebraic fraction, the chances are they're going to want you to factorise it. So let's start by doing that. So x squared take 11x. The highest common factor of both is x. So let's take that outside the bracket. That would become x brackets x plus 11. And then over here, hopefully you spot this. This is the difference of 2 squares where you've got x squared take a square number. So with the difference of 2 squares, you know it's going to be plus and minus the square root. If you don't, then just recap on difference of 2 squares. So then what do? I cancel out anything that is the same. So I've got x plus 11 here, x plus 11 there. So that would cancel out. So that would become x over x take 11. And that is your fully simplified quadratic. Okay, next we've got triple brackets. Okay, now I have a really helpful hint for triple brackets because I have seen people do this for many, many years. Obviously you can do whichever method you prefer, but the best way to do is expand a double bracket any way you want and then use a grid. So I'll show you how to do that. Now, what you need to notice is this is a triple bracket because over here, that's actually a double bracket. So 3x take 2 squared would be written like this. So sometimes people might not pick up on that. So don't be fooled. Squared means the whole thing is being multiplied by itself. So let's expand that, and you can do that however you like. So 3x times 3x would give you 9x squared. 3x take 2 would be minus 6x. 2 times -2 times 3x would be minus 6x again, and minus 2 times minus 2 would be positive 4. So let's simplify that. We'd get minus 12x plus 4. Okay, now here is the part where I recommend you use a little grid. So write your expanded double bracket here. So you've got 9x squared, then you've got minus 12x plus 4, and then over here write the bracket that's left over, which in this case is this little one here. So you've got 2x plus 1. And the reason I say this is just because it means that no term is left accidentally, and also it's a lot easier to simplify it. So 9x squared times by 2x, that would give you 18x cubed. 9x squared times by 1 is 9x squared. Minus 12 times by 2x is minus 24x squared. Minus 12x times 1 is minus 12x. 4 times 2x is 8x. 4 times 1 is 4. Okay, so let's write that out. 18x cubed take 24x squared. And what you can do is you can notice that these little diagonals, that they're the terms that simplify together. So you can write them out in order of powers. Plus 8x take 12x plus 4. So now let's see what we can simplify. Well, these two that I've circled, minus 24 minus 9x squared is, oh, sorry, that should be plus 9x squared. Minus 24 plus 9 is a minus 15x squared. And then you've got 8x take 12x, which would give you minus 4x plus 4. So this is how you show that something is. This is just an identity question with triple brackets. Okay, factorising. Okay, so now this is a calculator paper, so you can use a quadratic formula. If it's a tricky one, then I would recommend doing that. But if you can simplify it, then you might save time by actually just factorising it in your head. So over here you can see the coefficient of x squared is 5. Now if the coefficient of x squared is something that each term in the expression is divisible by, then just divide everything by that term. So 5 is divisible by 5, 10 is divisible by 5, and 15 is divisible by 5. So you automatically make your expression a lot simpler. So that would become x squared take 2x take 3. And then how do you simplify that? I mean, how do you factorise that? What are the factors of 3? 3 times 1. One of them needs to be a negative. And they also need to add to make -2. So how about 1 take 3? Or -3 plus 1. So x plus 1, x take 3. So the key here really is acknowledging that you can simplify it. You can divide each part of the expression by the coefficient of x squared. If not, then use the quadratic formula. Okay, manipulating a quadratic. So here we've got a quadratic and we want to solve it. Now, in order to solve a quadratic, you need to get it in the form ax squared plus bx plus c equals 0. So let's just do a bit of rearranging. So if we take 4x from both sides, we're left with x squared plus 6x take 32 equals 8. And then we just take 8 from both sides. So we're left with x squared plus 6x take 40 equals 0. Now, when you've got it equal to 0, that means that it's in a position for you to be able to solve it. And the way to solve is by factorising. So when you've got a quadratic, you solve it by factorising. So, once again, what are the factors of 40? Well, you got 5 times 8, 10 times 4, lots of other ones, but I've already realised that it's going to be 10 and 4. You know, one of them is going to need to be a negative because they multiply to make -40. So how could you combine them? Well, you know that 10 take 4 gives you 6. So that's your answer. So x plus 10, x take 4 equals 0. Now you've got your factorised version. So to solve it, we just need to do what we'd like. So if we had 3x equals 0, how would you figure out what x is? You just divide both sides by 3. So x would be, I mean, in this case, 0. So if you're dividing both sides by something, 0 divided by anything gives you 0, which is why we can do this. So if we divide both sides by x plus 10, 0 divided by anything is 0, which is why you're left with x take 4 is 0. And therefore, add 4 to both sides, so x would be 4. Do the same, but with the other part of the other bracket. So we divide both sides by x take 4, divided by x take 4, and you're left with x plus 10 equals 0. So if we take 10 from both sides, x is -10. So that is your other answer. A quadratic is always going to have 2 values. Well, not always, but most always. Very commonly, it's going to have 2 answers. So always look for that. Okay, so here we've got roots, turning points, and a quadratic graph all in one. So the key thing to know is that the roots, all that means is the coordinates where the graph crosses the x-axis. Okay, so you can find them by factorising your quadratic. So let's try factorising this. X squared take 2x take 3. Let's make it equal to 0 because along the x-axis y is always 0. So then factors of -3, -3 and 1. -3 plus 1 multiplies to make -3, and -3 plus 1 adds to make -2. So we've got x take 3, x take 1 equals 0. Now, just like before when we were solving the equations, hopefully by now you know that when you're solving it's the inverse. So the coordinate for x would be 3 and 1. Clearly this sketch is not drawn accurately. Oh no, wait, sorry, that's supposed to be +1. That's fine. So x would be -1. So your coordinates are 3, 0, and -1, 0. So that's the coordinates of the roots of the graph. So -1, 0, and 3, 0. Now what we need to do is work out the turning point. Now the turning point is this part here where the graph like physically turns. And in order to work that out, we need to do something called completing the square. So let's just get rid of this. So when we're completing the square, we're essentially writing the quadratic in a perfect square form. So x squared, take 2x, take 3. What we do is we make this into a perfect square, so we just halve the coefficient of x. There are lots of videos explaining this. If you don't know, just watch back to one of the turning point or quadratic ones. So half the coefficient of x, so that would be x take 1 squared. So if it was x take 1 squared, let's just expand that over here. X take 1 squared. If that was expanded, what would that give me? That would give me x squared take 2x plus 1. However, I want to have x squared take 2x take 3. So how do I get from x squared take 2x plus 1 to x squared take 2x plus 3? Well, the difference between 1 and -3 is -4. Okay, so that's how you'd write this in its completed the square form. So we know that the turning point would be, sorry, we don't need to write that, my brain. So the turning point, the x coordinate is always the inverse of what's inside your bracket. So x would be 1, and the y coordinate is just what the leftover bit. So once you've completed the square, the leftover bit. So y would be -4. So the turning point of this graph would be 1, -4. Okay, a graph has equation y equals 3x. Write the coordinates of the y-intercept. So this is like an exponential graph. 3 to the power of x is going to look something like this. Now, the y-intercept is where it crosses the y-axis. And what do we know about the x-coordinate on the y-axis? Well, x is always going to be 0. So all we do is we substitute x equals 0 into that. What is 3 to the power of 0? Well, anything to the power of 0 is 1. So the coordinates of the y-intercept would be 0, 1. Then we've got composite functions. Now these are slightly nasty, but they're absolutely fine if you just work your way from the inside out. So g of x, we need to work out f of g of x. Okay, so what we want to do is substitute g of x, which is this, into f of x. So wherever we see an x, we're going to put what I've highlighted in pink. So f of g of x is going to be x squared plus 4 over x squared plus 4 take 4. Okay, so all I've done is I've substituted, oh, I didn't mean to move that. I've substituted g of x into f of x. So wherever I saw an x, I substituted this that I've highlighted in pink. So now I need to simplify it. So that would become x squared plus 4 over 4 take 4 becomes 0 over x squared. Now when you've got fractions, hopefully you remember from adding or subtracting fractions that you can write them as two separate fractions. So that is the same as x squared over x squared plus 4 over x squared. And anything divided by itself is 1. So x squared over x squared is 1. 4 over x squared. Well, to write this differently, they've told me that I want to write it in the form b of x to the power of n. So x squared, 4 over x squared, that could be written as 4 lots of So 4 over x squared is the same as 4 lots of 1 over x squared. Okay, and how could I write 1 over x squared? That's the reciprocal of x squared. So like when we have fractions, if I said what's 3 to the power minus 1, that's 1 over 3. Similarly, if I said what's x to the power of minus 2, that would be 1 over x squared. It's the reciprocal, it's 1 over that thing. So I could write that as 4 times by 1 over x squared, which I've said can be written as x to the power of minus 2. So our final bit would be 1 plus 4x to the power of minus 2. And that's how you'd do that one. So the composite function part is the first part, you're just substituting things into each other. And then the next bit is just a bit of a tricky rearranging and writing the reciprocal. Okay, then we've got an arithmetic progression. Now, arithmetic progression just means that there's a constant value that the sequence is increasing or decreasing by. So 11, 16, 21, what's increasing? Each time the difference is 5. Use 3 of the numbers to make a different arithmetic progression. Okay, so we're just looking for 3 numbers that have a different difference. So perhaps we could have 14, 21 and 28. So 14, 21, 28, because the difference each time is plus 7. Okay, so we've got our terms 14, 21, 28, and we want to work out the nth term. Now to work out the nth term, you find the difference between each of these terms, which in this case is 7. So I'd say 7n because that's the times tables that it's going up in. And then if I wrote out the 7 times tables above here, well, it's similar, but it's been shifted. So how much has it been shifted by? How do you get from 7 to 14? You add 7. And that's it. So that's your nth term of the sequence. Okay, geometric sequences. So these are where the sequence, the difference between each term is being multiplied or divided. So in this case, what's happening each time? Well, each number is half of the previous number. So you could say it's being times by a half, or you could say it's being divided by 2. So how would we work out the 6th term? Well, we've been given 1, 2, 3, 4, 5. So to work out the 6th term, we just need to divide 7.5 by 2, which is 3.75. Describe the rule of the sequence. Well, you just halving the previous term, or you could say you're dividing the previous term by 2. And then the final thing for algebra is just another way of using the nth term. So we've been told that the nth term of a sequence is n squared over 3. Find the third term. So what the nth term is a formula for working out any term. So n represents the term. So in this case, we're trying to find the third term, so n would be 3. So all I do is substitute that into my formula. 3 squared over 3, that would be 9 over 3, which is 3. So the third term is 3. And then it says which term in the sequence is the first to have a value greater than 60. So what I want to do is make this equal to 60 to figure out which term that would be. Rearrange it. So let's times both sides by 3. So n squared is 180, and then do the square root. Where's my calculator gone? So n would be the square root of 180, which is square root of 180, 13.416. So n is 13.416. So the 13.416 term would be greater than 60, but terms can only be integers. So therefore we know it's going to have to be the 14th term, because the 13th term would just be a bit less. If you're not sure whether it's going to be the 13th or the 14th, just substitute it in. So substitute 13 squared divided by 3 would have given you 56.3 recurring, so that's not above 60. So then we try the 14th term. 14 squared divided by 3 is 65.3 recurring. Another way you could have done this is work out each term, but that would have been quite time consuming. So try and make it equal to what you want it to be. Okay, so highest common factor. Now there are quite a few ways you can do this, but I'm going to show you the Venn diagram way, because the next question you're being asked to work out the lowest common multiple of the same set of numbers. So what do I do for the Venn diagram method? I use my product of primes. So I do myself a little factor tree. So I say to myself, what two numbers multiply to make 96? Well, 2 times 48. 2 is a prime number, so I circle it. What two numbers multiply to make 48? 2 times 24. 2 is prime, so I circle it. What about 24? I could go rogue and go 3. So 3 times by 8, or I could have done any two numbers. And then how do I make 8? Well, that's 2 times by 4 and 2 times by 2. Okay, so 96 as a product of its primes would be 2 times 2 times 1, 2, 3, 1, 2, 3 times by 3. Okay, I'm not going to put it into factor form just yet. I can if I want, but up to you. And then 108. So that would be 2, circle the prime, times by 54. And then 2 times by 27. And then 3 times by 9, which is 3 times by 3. Okay, so 108 is 2 times by 2 times by 1, 2, 3 times 3 times 3. Cross them all out. Okay, so I've got all of my prime factors of 96 and 108. And now what I want to do is write them all in a little Venn diagram. So how do I do that? I just draw myself a little Venn diagram. Don't actually need to draw that box, but here we've got your two circles. So you've got 96 here, 108 here. Actually, I'm going to get rid of that rectangle. Okay, so what do we have that is common to 96 and 108? So you've got a 2. So I'd write 2 there. You only write it once. You've got another 2. So you write that in the middle. And then you've got 3. That isn't common. So over here we've got 2, 2, 3. Then what's left over? You've got 2, 2, 2. So 2 times 2 times 2 over here. And for 108, you've got 3 times 3. Now, to work out the highest common factor, all you need to do is multiply the numbers in the intersection. So the numbers that are both multiples of factors of 96 and 108. So the highest common factor is going to be 2 times 2 times 3, which is 12. Okay, now I'm going to carry this over to the next screen where I'm working at the lowest common multiple. So let's just draw that out again. I've done all the hard work. 96, 108, and then I've got 2, 2, 2. What did I have in the middle? Well, I know it multiplied to 12, so I'll just write 12 there and 3 and 3. Now, to work out the lowest common multiple, what you do is you just multiply everything inside of your Venn diagram. And this is a lot quicker than doing the listing strategy of saying 96, 108 and writing out all of their multiples. So 2 times 2 times 2 times 12 times 3 times 3 is 864. And that's why I chose the Venn diagram, because personally, I think that's a lot easier. You could just sit there writing numbers out on your calculator, saying 96 plus 96, which would be 192, plus 96 again, 288, and so forth. But personally, Venn diagram method, much quicker. Okay, next we've got an error interval. So an error interval is just where we've rounded something to a certain level of accuracy. We don't actually know what the original amount is. So something has been rounded to 8.47. Okay, to 2 decimal places. So that's the second decimal place. So what would 2 decimal places, the decimal place above and below it be? It would be 8.46, and here it would be 8.48. So the error interval is looking for the halfway point between them. So halfway between 8.46 and 8.47 is 8.465, because if you were to round 8.465 to 2 decimal places, You look at the 6, you look next door, it's more than 5, so you add one more. That would round to 8.47. So 8.465 is less than or equal to x, which is less than 8.475, which is the midpoint over here. Now, I say that it's less than because if it was 8.475, then to 2 decimal places, that would round to 8.48. So it can't actually be 8.475. It can be anything below that. So it could be 8.47499 recurring, but it cannot be 8.475. So that's my error interval. You always write it in the form of something is less than or equal to x, which is less than the largest thing. Okay, write the following numbers in descending order. So make sure you pay attention to the wording. So let's write these all out. So 0.14, I'm just going to write them all out with like lots of zeros so that we can compare them. 0.141 recurring, well, the recurring part is the 1. Then we've got 0.14141414 recurring. Then you've got 0.14 recurring. And then you've got 0.141. 141. Okay, so let's look at this. Descending order, I'm going to write it in ascending order first because that's the way my brain likes things, and then I'll switch it around. So the smallest number, you look at the first column, well, they're all the same. You look at the second column, once again, they're all the same. And so you look at the third column. So what's the smallest one? Or 0 is the smallest, so that must be the smallest number. So 0.14 is the smallest value. Then you look at the third, the next smallest. They've all got 1. So what we're going to do is look at the next column. So here we've got 1, then 4, then 1. Okay, so these two are competing to be smallest. We look at the next column, and let's maybe circle it in a different color just so you can see. And that 1 is smaller than 4. So this 0.141 recurring is going to be your next number. So actually, let's cross out the ones that we've used. Okay, then we go back to this column. So we've got 1 and 4, and then 1 is less than 4. So this will be our third value, 0.141 recurring like that. Let's cross that out. And then we'd be left with over here 0.141. So what was the original one? That was 14 recurring like that, which leaves us with our last one, which is 0.14 recurring. Now it said in descending order, which means largest to smallest. So I'm just going to reverse it, go from here and go backwards. So in descending order, it would be 0.14, 0.14 like that, 0.141, 0.141 recurring, and 0.14. And that is my answer. Okay, next we've got recurring decimals. So here it says prove algebraically. Now, obviously this is a calculator paper. You could just type 0.42 recurring into your calculator. It would convert it for you. However, you need to show this algebraically. So we start by saying that x is 0.42. X is always going to be your original value. Now, what can we do? We could manipulate that. If we multiply that by 10, that would be 4.2 for recurring, so forth. So then we can multiply it by 100, which would give you 42.42 recurring. Now, what we want to do is get it so that the decimal part is equal, because then we can subtract it and it would cancel out to make 0. So we've got x and we've got 100x. So if we said 100x is 42.42 recurring, and x is 0.42 recurring, and we subtracted that, we'd be left with 99x equals, well, 0.42 recurring is going to cancel out. 42 take away 0 is 42. So I'm just hoping I've done it. So then we'd say we divide both sides by 99. So x is 42 over 99. Can I simplify that? Well, let's see. If I divide it by 3, divide by 3, divided by 3 is 14 over 33. And that's how you prove that algebraically. Okay, now we've got product rule for counting. This is also known as combinations, and people tend to get really confused by this, but it's super easy if you just think about all of your options. So Casey is choosing an outfit for prom night. She has 6 pairs of earrings, 5 bracelets, 7 necklaces, 5 pairs of shoes. She wants to wear one of each accessory along with her dress. So how many types of accessory are there? 1, 2, 3, 4. We've got earrings, bracelets, necklaces and shoes. Okay, how many types of earrings do we have? 6. How many types of bracelets? 5, 7 and 5. And all we do is we just multiply all of our options, because each of those 6 earrings could be combined with 5 different bracelets, and then from those 5 different bracelets, 7 different necklaces and 5 pairs of shoes. So for when we've got combinations, the product rule is we multiply. So 6 times 5 times 7 times 5. How many different ways can she wear her outfit? 6 times 5 times 7 times 5 is 1050. Next part, she also decides that she wants to wear a hair accessory. The total ways she can combine her outfit are now 4200. So I know that my original combinations times by however many hair accessories she has must equal 4200. How many choices of hair accessory did she have? Well, if I divide both sides by 1050, x would be 4200 divided by 1050 is 4. So she must have 4. Okay, so here we've got 3 topics in one go. So compound shape, quadrilateral and trigonometry. So we are told that this compound shape is made using a triangle and a rectangle. We know it's a right angle triangle because we've got that little sign there, which means I can use trigonometry or Pythagoras. And I need to find the perimeter of the shape. Okay, so I know what this side is here, 13 centimeters. Therefore, this length here is also going to be 13 centimeters. I know this length here is 5 centimeters. However, I have 2 lots of missing lengths over here and over here. Now, how can I work out the missing length of the rectangle? Well, it's going to be the same as the missing length of this triangle here. So I could use trigonometry there. So let's just draw out that triangle over here and label it. Now, the first thing to do when you're using trigonometry, write out your SOHCAHTOA just to help you, just to remember which ratios go with which. So label your triangle. First side to label is the hypotenuse, because it's always going to be the angle, the side opposite the right angle. Then you will be given an angle. In this case, it's 38 degrees over here. And your opposite side is the side that is opposite your given angle. And then you've got the adjacent, which is the side that is next to, adjacent to your angle. So here we've got opposite, adjacent and hypotenuse. And we want to figure out the opposite, because that is this side here. We've been given the length of the adjacent. So the 2 sides we're going to use is opposite and adjacent, which goes into the tan ratio. Tan is opposite over the adjacent. So the formula is tan theta is opposite over the adjacent. I'm just going to substitute what I know. So I know that theta, that's the angle, is 38 degrees. The opposite is what I'm trying to figure out. So let's just call that x. And the adjacent is 5. What do? I need to rearrange this formula to get x on its own. So 5 tan 38 equals x. So just plug that into your calculator. And what do you get? 5 tan 38. 3.9064. So let's round that to 3.91. So x is 3.91. I would recommend that you don't round until the very, very end. I'm just rounding because I have a lack of space. So this side here is 3.91, which means that this length here will also be 3.91. So I've worked that out. Now what do I need to do? Well, I need to work out this length here, the hypotenuse. So I've got my triangle already labelled, but I'm going to change the sides that I'm using because I want to figure out the hypotenuse, and I've been given the adjacent. So which ratio do you use when you've got the adjacent and the hypotenuse? That would be cos, because A and H. So you've got cos theta equals adjacent over hypotenuse. That's just the formula. And substitute what we know. So we know cos 38 equals adjacent, which is x, the side that I don't know the value of, over 5. Oh no, hold on, I wrote that wrong. It would be 5 over x. Okay, so this is a slightly trickier one where x is the denominator. What you have to do is rearrange your equation. So multiply both sides by x. So you'd be left with x cos 38 equals 5. And then you divide both sides by cos 38. So 5 over cos 38. So type that into your calculator. That's a fraction. 5 divided by cos 38 is 6.34. So x here is 6.34509. So let's round it to 6.35 actually. Once again, if I were you, I'd write everything out. I'm just trying to make the most of space. So here, that length here is 6.35. And what does perimeter mean? It means the distance all the way around the shape. So I'm just going to do 3.91 plus 13 plus 6.35 plus 5 plus 13. Add it all together, and what do you get? The perimeter is, I'm just going to use the calculator, 3.91 plus 13 plus 6.35 plus 5 plus 13 is 41.26 centimetres. Hopefully that's right. I'm not thinking very straight. Okay, so find the surface area of a cylinder. So when you've got a cylinder, think of it as a I had a toilet roll and now I've lost it. But imagine a toilet roll. It's like this little piece of cardboard, right? If you cut it and you unraveled it, you would just get a rectangle. Okay, so a cylinder, if you unraveled it, it's just a rectangle. It's just been curved to form like a nice cylinder. So the area of the rectangle would be, obviously here we've got 12. And then this length here, if you think of the cylinder being unraveled, that's going to be like the circle unraveled. So therefore, the length here is the circumference of the circle. Okay, so that's how you work out the cylinder. The surface area of the cylinder. And then of course its area, so you've got this little circle bit here and this little circle bit here, so you've got those two. And how do you work out the area of a circle? Area of a circle is pi times radius squared. So what's the radius here? It's 3, so the area of the circle would be pi times 3 squared. Same over here, pi times 3 squared. What would the circumference be? Well, circumference is pi times diameter. So the diameter would be 6. So the circumference here would be pi times 6, which is 6 pi. I'm going to just work in pi because it just makes everything a lot simpler. You can write all the values out if you like. So we've got 6 pi times by 12 as this area here. So 6 times 12 is 72, so the area here would be 72 pi. The area here, 3 squared is 9, so that would be 9 pi, and the area here would be 9 pi. And all I need to do to work out the total surface area would be add them all together. So that 72 pi plus 18 pi leaves me with, is that 18 pi? 90 pi. And then I just type that into my calculator. 90 pi is 282.743, so I'd round it to 7.4 centimetres squared. It might ask you to round it to significant figures or decimal places, but yeah. Okay, next we've got some fun circle theorems. Okay, so A, B and C are points on a circle, centre 0, centre O. We've got tangents to a circle. Now, what do we know about a tangent to a circle? Well, a tangent and a radius, they always meet at 90 degrees. Okay, so if you've got a radius of a circle and it meets a tangent, it's always going to be at 90 degrees. So I know that this angle here and this angle here, I don't know why this circle, must be 90 degrees because the radius meets a tangent. You're probably going to need to write reasons as well. So radius meets tangent at 90 degrees. So that's your first little circle theorem. Then, I haven't actually read the question. What we're trying to find out, work out the size of angle ABC. So let's just, ABC is this angle here. Okay, so that's what I'm trying to work out. Great. So let's continue with this. So we've worked out these two angles. What's this shape here? That is a quadrilateral. What do you know about angles in a quadrilateral? They add up to 360. So 360, take 90, take 90, take 40. That would be 140. Let me just double check because I don't want to go. So 360, take 90, take 90, take 40 is, yeah, 140. So this angle here would be 140 degrees. And you'd say your next circle theorem would be, what did I just say? Angles in a quadrilateral. Angles in a quadrilateral sum to 360. So we know that this angle here is 140. Now another circle theorem rule, let's write it in pink, is that the angle subtended at the circumference, and all that just means is like the angle created by like the two arcs. So here you've got these two lengths here. The angle created by them at the circumference is half that at the center. Okay, so whatever the angle at the center is, the one at the circumference is going to be half of that. The one at the center is always double that at the circumference. So therefore this angle here is going to be 70 degrees. So angle ABC is 70 degrees. And the reasons you would have used is radius meets tangent at 90, angles in a quadrilateral sum to 360. The angle subtended at the circumference is half that at the center. Okay, next we've got the sine rule. Okay, so what is the sine rule? Well, A over sine A equals B over sine B equals C over sine C. You're given this in your formula sheet. So I know this is a quadrilateral and I want to work out the length of AD here. AD, so over here. Well, that's not very nice. We haven't been given much information. Okay, so what have I been given? So, okay, when you're dealing with the sine rule, the little letters are a side and then the big letters, they represent an angle. Okay, so in this case, I'm going to label, okay, another thing that people always do wrong is they don't label their triangle. I know the triangle is labeled ABCD, but it is up to you. You can rename it and always rename it so that it makes sense to what you're trying to do. So in this case, I've got the side A here is 8 centimeters and the angle opposite it here is A. So in this case, it works. So 8 over sine 35 is equivalent to, now what, side am I trying to work out? So I'm trying to work out AD, and in order to do that, I'd need to work out B. But I could just use trigonometry for that. So, okay, so to begin with, let's just work out this side here because that's going to help us with the sine rule. So the sine rule is what we use if we don't have, if our triangle is not a right angle triangle, but this triangle is. So let's just work out this length here. So if this was a right angle triangle, that would be 35 degrees. That would be 8 centimeters. That would be the hypotenuse. That would be the opposite, and this would be the adjacent. So therefore, let's just label it on here. I forgot to mention that at the very beginning. The sine rule, cosine rule can only be used on non-right angled triangles. If it's a right angled triangle, you use trigonometry or Pythagoras. What was I doing? Okay, so we've got SOHCAHTOA. Which one are we going to use? We want to figure out we want to figure out the hypotenuse. So we've got H, and we've been given the opposite. So O and H, that is sine theta is opposite over hypotenuse. So what information have we been given? Sine 35 is opposite, which is 8 over the hypotenuse, which is x. Let's rearrange that. X sine 35 is 8, so x would be 8 over sine 35. So let's do that. 8 over sine 35 is 13.95, or round it to. So x is 13.95. Okay, I'm trying to work out the length of AD. So now this is where I'm going to use the sine rule. Okay, so let's do it in a different colour. So let's label, this is my new triangle. So ACD is my triangle. I have this length and the triangle, the angle opposite it is the one that goes with it. So let's I'm going to rename this as A, okay, because I want to, and this can be B, and therefore that will be C. So A over sine A, so little side A, 13.95 over sine A, sine 55 is going to be equal to this is going to be little c, c over sine c. So all I'm doing, I've renamed it ABC because it's totally up to me to decide which one's which. What matters is that the little letter and the big letter, they are opposite each other. So this is going to be little a, little side A, opposite big A, little c, opposite C. So now what do I need to do? Well, I can just rearrange this equation to figure out what C is. So multiply both sides by sine 108, and then let's see what we get. So 13.95 over sine 55 times by sine 108 is 16.17 rounded. I've rounded that, and that is how you work that out. So see, the length of AD is 16.17. Now this is made a little bit more complicated because obviously we had to use trigonometry first. The key thing is, remember, if it's a right angled triangle, so if it's right angled, you use trig or Pythagoras. And then if it's non-right angled, that's where you use the sine rule and the cosine rule. Okay, now let's try the cosine rule. So the cosine rule, once again, you are given this, but it's a squared equals b squared plus c squared take 2bc cos a. Now, once again, you can label your triangle however you want to. A, B, and C. Personally, what I would do is, like, even if this one's right, I haven't looked at it, but if this one's right, I don't care. Rub them out and you rename it. So I am trying to find the length of, oh damn, I forgot which one's A and which one's B now. I'm trying to find out the length of AB. Okay, so this is the line I'm trying to find the length out of. And remember, the little letters are sides, the big letters are angles. So the only angle I have been given is 38 degrees. So this I'm going to call my angle A. Okay, and this is why I say rename it, because otherwise people get confused and they think they need to work out this angle, that angle. No, just rename it so that it's nice. So A, the big angle, is here, which means this is the little a. So a squared is going to be equal to, and then b and c, it doesn't really matter which one's which, but a squared equals, let's just say this is b. So 7 squared plus 8 squared, take away 2 times b, 7 times 8 times cos a, which is 38. So really the cosine rule is just about substituting. So all you need to do once you've decided which one's which. So then let's work that out bit by bit. So a squared is going to be 49 plus 64, take 2 times 7 times 8 is 112, cos 38. I'm just doing it bit by bit so you can see what's happening. Add 49 plus 64, which is 113. And then 112 cos 38 is 88.257, blah, 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 blah. Simplify that, so 113, takeaway answer is 24.74. So if a squared is 24.7427, blah, 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 to work out a, you just do the square root. So that would give you, square root of answer is 4.9742. So a, or AB, the length, is 4.9742. And then we've got some vector arithmetic. Okay, so we've got column vectors. Now, all we do is treat them like algebra. Every column vector is just a movement. The top coordinate is the x, so it's the movement along the x-axis. The bottom number is the movement along the y-axis. So if f is -2, 3, 2f would be 2 times by this. So 2 lots of -2 would be -4. 2 lots of 3 would be 6. So 2f would be -4, 6. G just remains itself. Okay, so when we're subtracting, we subtract the top parts and then the bottom parts. So -4, take 4 is -8. And then 6, take -2. Remember, a negative and a negative make a positive. So that is +8. Okay, now we've got 3g. So if g is 4, 3 lots of that would be 3 times 4 is 12. 3 times -2 is -6. And I take away 2f. Well, I've already worked out what 2f is, so I could just write it here. And then I just subtract. So 12, take -4 is 16, because a negative and negative becomes a positive. And then -6, take 6 is -12. And that's all you do for your vector arithmetic. And lastly, we've got bearings. Okay, now the key thing about bearings is that you have to pay attention to where they say it's going from. That's like your starting point. So the bearing of a ship from a lighthouse is 108. So we could just say like our little lighthouse is here. And the bearing of a ship from a lighthouse is 108. So just think about your angles. That's 90 degrees. So you know that the bearing has to be like more than 90 degrees. So you just do a rough sketch and you could say 108 degrees. So that's your lighthouse, and the bearing of a ship from a lighthouse is 108. So from is your starting point. So it says it's from the lighthouse. So the lighthouse is where you start from. And you get to your ship. Now, the rules of bearings, the first rule is you always have to start from due north, which just means up, like north. Second rule is they always have to be written as 3 digits. Third rule is you always start from where it says from. Okay, so that's the bearing of the ship from the lighthouse. And what we need to do now is find the bearing of the lighthouse from the ship. Oh, and the fourth rule is you have to go clockwise. So from the ship, I have to go clockwise, and that would be my bearing there. Okay, so I need to work that out. Now, because the reason like bearings are so nice is because they always start from due north, which means, oh, why does it rub it out? Which means that these two lines here are going to be parallel. And what do I know about interior angles on parallel lines? Well, co-interior angles sum to 180 degrees. So I use that angle fact to figure out what this is. 180, take 108 is 72 degrees. So that angle there is 72. What about angles at a point? You know that angles at a point sum to make 360. So to work out this, the bearing of the ship, I do 360, take 72, which is 360 take 72 is 288. Okay, so that must mean that this angle here is 288 degrees. So the bearing of the lighthouse, to get from the lighthouse from the ship, you start where it says from, which is the ship, and you have to go clockwise. So this angle here is 288. Therefore, your answer is 288 degrees. And that is all for geometry and measures. And that's all for part 1. Part 2 is shortly to follow on ratio, statistics and probability.